Chapter 13 of Curiosities of the Sky. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. This reading by Allison Hester of Athens, Georgia. Curiosities of the Sky by Garrett Serviss. Chapter 13. The Great Mars Problem. Let any thoughtful person who is acquainted with the general facts of astronomy look up at the heavens some night when they appear in their greatest splendor, and ask himself what is the strongest impression that they make upon his mind. He may not find it easy to frame an answer, but when he has succeeded it will probably be to the effect that the stars give him an impression of the universality of intelligence. They make him feel, as the sun and the moon cannot do, that his world is not alone, that all this was not made simply to form a gorgeous canopy over the tents of men. If he is of a devout turn of mind, he thinks, as he gazes into those fathomless deeps and among those bewildering hosts, of the infinite multitude of created beings that the Almighty has taken under his care. The narrow ideas of the old geocentric theology, which made the earth God's especial footstool and man his only rational creature, fall away from him like a veil that has obscured his vision. They are impossible in the presence of what he sees above. Thus, the natural tendency, in the light of modern progress, is to regard the universe as everywhere filled with life. But science, which is responsible for this broadening of men's thoughts concerning the universality of life, itself proceeds to set limits. Of spiritual existence it pretends to know nothing, but as to physical beings it declares that it can only entertain the supposition of their existence where it finds evidence of an environment suited to their needs, and such environment may not everywhere exist. Science, though repelled by the antiquated theological conception of the supreme isolation of man among created beings, regards with complacency the probability that there are regions in the universe where no organic life exists, stars which shine upon no inhabited worlds, and planets which nourish no animate creatures. The astronomical view of the universe is that it consists of matter in every stage of evolution, some nebulous and chaotic, some just condensing into stars, suns, of every magnitude and order, some shaped into finished solar bodies surrounded by dependent planets, some forming stars that perhaps have no planets and will have none, some constituting suns that are already aging and will soon lose their radiant energy and disappear, and some aggregated into masses that long ago became inert, cold, and rayless, and that can only be revivified by means about which we can form conjectures, but of which we actually know nothing. As with the stars, so with the planets, which are the satellites of stars. All investigations unite to tell us that the planets are not all in the same state of development. As some are large and some are small, so some are, in an evolutionary sense, young, and some old. As they depend upon the suns around which they revolve, for their light, heat, and other forms of radiant energy, so their condition varies with their distance from those suns. Many may never arrive at a state suitable for the maintenance of life upon their surfaces. Some which are not at present in such a state may attain it later, and the forms of life themselves may vary with the peculiar environment that different planets afford. Thus we see that we are not scientifically justified in affirming that life is ubiquitous, although we are thus justified in saying that it must be, in a general sense, universal. We might liken the universe to a garden known to contain every variety of plant. If, on entering it, we see no flowers, we examine the species before us and find that they are not of those which bloom at this particular season, or perhaps they are such as never bear flowers. Yet we feel no doubt that we shall find flowers somewhere in the garden, because there are species which bloom at this season, and the garden contains all varieties. While it is tacitly assumed that there are planets revolving around other stars than the sun, it would be impossible for us to see them with any telescope yet invented, and no instrument now in the possession of astronomers could assure us of their existence. So the only planetary system of which we have visual knowledge is our own. Excluding the asteroids, which could not from any point of view be considered as habitable, we have in the solar system 8 planets of various sizes and situated at various distances from the sun. Of these 8, we know that one, the Earth, is inhabited. The question then arises, are there any of the others which are inhabited or habitable? Since it is our intention to discuss the habitability of only one of the 7 to which the question applies, the rest may be dismissed in a few words. The smallest of them, and the nearest to the sun, is Mercury, which is regarded as uninhabitable because it has no perceptible supply of water and air, and because, owing to the extraordinary eccentricity of its orbit, it is subjected to excessive and very rapid alterations in the amount of solar heat and light poured upon its surface, such alterations being inconsistent with the supposition that it can support living beings. Even its average temperature is more than 6½ times that prevailing on the earth. Another circumstance which militates against its habitability is that, according to the results of the best telescopic studies, it always keeps the same face toward the sun, so that 1/2 of the planet is perpetually exposed to the fierce solar rays, and the other half faces the unmitigated cold of open space. Venus, the next in distance from the sun, is almost the exact twin of the earth in size, and many arguments may be urged in favor of its habitability, although it is suspected of possessing the same peculiarity as Mercury, in always keeping the same side sunward. Unfortunately, its atmosphere appears to be so dense that no permanent markings on its surface are certainly visible, and the question of its actual condition must, for the present, be left in abeyance. Mars, the first planet more distant from the sun than the earth, is the special subject of this chapter, and will be described and discussed a few lines further on. Jupiter, Saturn, Uranus, and Neptune, the 4 giant planets, all more distant than Mars, and each more distant than the other in the order named, are all regarded as uninhabitable because none of them appears to possess any degree of solidity. They may have solid or liquid nuclei, but exteriorly they seem to be mere balls of cloud. Of course, one can imagine what he pleases about the existence of creatures suited to the physical constitution of such planets as these, but they must be excluded from the category of habitable worlds in the ordinary sense of the term. We go back, then, to Mars. It will be best to begin with a description of the planet. Mars is 4,230 miles in diameter. Its surface is not much more than 1/4 as extensive as that of the earth, 285 thousandths. Its mean distance from the sun is 141,500,000 miles, and 48,500,000 miles greater than that of the earth. Since radiant energy varies inversely as the square of distance, Mars receives less than half as much solar light and heat as the earth gets. Mars' year, period of revolution around the sun, is 687 days. Its mean density is 71% of the earth's, and the force of gravity on its surface is 38% of that on the surface of the earth, i.e., a body weighing 100 pounds on the earth would, if transported to Mars, weigh but 38 pounds. The inclination of its equator to the plane of its orbit differs very little from that of the earth's equator, and its axial rotation occupies 24 hours, 37 minutes, so that the length of day and night, and the extent of the seasonal changes on Mars, are almost precisely the same as on earth. But owing to the greater length of its year, the seasons of Mars, while occurring in the same order, are almost twice as long as ours. The surface of the planet is manifestly solid, like that of our globe, and the telescope reveals many permanent markings on it, recalling the appearance of a globe, on which geographical features have been represented in reddish and dusky tints. Around the poles are plainly to be seen rounded white areas, which vary in extent with the Martian seasons, nearly vanishing in summer and extending widely in winter. The most recent spectroscopic determinations indicate that Mars has an atmosphere perhaps as dense as that to be found on our loftiest mountain peaks, and there is a perceptible amount of watery vapor in this atmosphere. The surface of the planet appears to be remarkably level, and it has no mountain ranges. No evidences of volcanic action have been discovered on Mars. The dusky and reddish areas were regarded by the early observers as respectively seas and lands, but at present it is not believed that there are any bodies of water on the planet. There has never been much doubt expressed that the white areas about the poles represent snow. It will be seen from this brief description that many remarkable resemblances exist between Mars and the earth, and there is nothing wonderful in the fact that the question of the habitability of the former has become one of extreme and widespread interest, giving rise to the most diverse views, to many extraordinary speculations, and sometimes to regrettably heated controversy. The first champion of the habitability of Mars was Sir William Herschel, although even before his time the idea had been suggested. He was convinced by the revelations of his telescopes, continually increasing in power, that Mars was more like the earth than any other planet. He could not resist the testimony of the polar snows, whose suggestive conduct was in such striking accord with what occurs upon the earth. Gradually, as telescopes improved and observers increased in number, the principal features of the planet were disclosed and charted, and areography, as the geography of Mars was called, took its place among the recognized branches of astronomical study. But it was not before 1877 that a fundamentally new discovery in areography gave a truly sensational turn to speculation about life on the red planet. In that year Mars made one of its nearest approaches to the earth, and was so situated in its orbit that it could be observed to a great advantage from the northern hemisphere of the earth. The celebrated Italian astronomer Schiaparelli took advantage of this opportunity to make a trigonometrical survey of the surface of Mars, as coolly and confidently as if he were not taking his sights across a 35-million-mile gulf of empty space, and in the course of this survey he was astonished to perceive that the reddish areas, then called continents, were crossed in many directions by narrow, dusky lines, to which he gave the suggestive name of canals. Thus a kind of firebrand was cast into the field of astronomical speculation, which has ever since produced disputes that have sometimes approached the violence of political faction. At first the accuracy of Schiaparelli's observations was contested. It required a powerful telescope and the most excellent seeing to render the enigmatical lines visible at all, and many searchers were unable to detect them. But Schiaparelli continued his studies in the serene sky of Italy, and produced charts of the gridiron face of Mars containing so much astonishing detail that one had either to reject them totally or to confess that Schiaparelli was right. As subsequent favorable oppositions of Mars occurred, other observers began to see the canals, and to confirm the substantial accuracy of the Italian astronomer's work, and finally few were found who would venture to affirm that the canals did not exist, whatever their meaning might be. When Schiaparelli began his observations, it was generally believed, as we have said, that the dusky areas on Mars were seas, and since Schiaparelli thought the canals invariably began and ended at the shores of the seas, the appropriateness of the title given to the lines seemed apparent. Their artificial character was immediately assumed by many because they were too straight and too suggestively geometrical in their arrangement to permit the conclusion that they were natural watercourses. A most surprising circumstance noted by Schiaparelli was that the canals made their appearance after the melting of the polar snow in the corresponding hemisphere had begun, and that they grew darker, longer, and more numerous in proportion as the polar liquidation proceeded. Another very puzzling observation was that many of them became double as the season advanced. Close beside an already existing canal, and in perfect parallelism with it, another would gradually make its appearance. That these phenomena ever existed and were not illusions were proved by later observations, and today they are seen whenever Mars is favorably situated for observation. In the closing decade of the 19th century, Mr. Percival Lowell took up the work where Schiaparelli had virtually dropped it, and soon added a great number of canals to those previously known, so that in his charts the surface of the wonderful little planet appears covered with a spider's web, the dusky lines crisscrossing in every direction with conspicuous knots wherever a number of them come together. Mr. Lowell has demonstrated that the areas originally called seas, and thus named on the earlier charts, are not bodies of water, whatever else they may be. He has also found that the mysterious lines do not, as Schiaparelli supposed, begin and end at the edges of the dusky regions, but often continue on across them, reaching in some cases far up into the polar regions. But Schiaparelli was right in his observation that the appearance of the canals is synchronous with the gradual disappearance of the polar snows, and this fact has become the basis of the most extraordinary theory that the subject of life in other worlds has ever given birth to. Now, the effect of such discoveries, as we have related, depends upon the type of mind to whose attention they are called. Many are content to accept them as strange and inexplicable at present, and to wait for further light upon them. Others insist upon an immediate inquiry concerning their probable nature and meaning. Such an inquiry can only be based upon inference proceeding from analogy. Mars, say Mr. Lowell and those who are of his opinion, is manifestly a solidly encrusted planet like the earth. It has an atmosphere, though one of great rarity. It has water vapor, as the snows in themselves prove. It has the alternation of day and night, and a succession of seasons closely resembling those of the earth. Its surface is suggestively divided into regions of contrasting colors and appearance, and upon that surface we see an immense number of lines geometrically arranged, with a system of symmetrical intersections where the lines expand into circular and oval areas, and all connected with the annual melting of the polar snows in a way which irresistibly suggests the interference of intelligence directed to a definite end. Why, with so many concurrent circumstances to support the hypothesis, should we not regard Mars as an inhabited globe? But the differences between Mars and the earth are in many ways as striking as the resemblances. Mars is relatively small. It gets less than half as much light and heat as we receive. Its atmosphere is so rare that it would be distressing to us, even if we could survive in it at all. It has no lakes, rivers, or seas. Its surface is an endless prairie, and its canals are phenomena utterly unlike anything on the earth. Yet it is precisely upon these divergences between the earth and Mars, this repudiation of terrestrial standards, that the theory of life on Mars, for which Mr. Lowell is mainly responsible, is based. Because Mars is smaller than the earth, we are told it must necessarily be more advanced in planetary evolution, the underlying cause of which is the gradual cooling and contraction of the planet's mass. Mars has parted with its internal heat more rapidly than the earth. Consequently, its waters and its atmosphere have been mostly withdrawn by chemical combinations. But enough of both yet remain to render life still possible on its surface. As the globe of Mars is evolutionally older than that of the earth, so its forms of organic life may be proportionally further advanced, and its inhabitants may have attained a degree of cultivated intelligence much superior to what at present exists upon the earth. Understanding the nature and the causes of the desiccation of their planet, and possessing engineering science and capabilities far in advance of ours, they may be conceived to have grappled with the stupendous problem of keeping their world in a habitable condition as long as possible. Supposing them to have become accustomed to live in their rarefied atmosphere, a thing not inconceivable, since men can live for a time at least in air hardly less rare. The most pressing problem for them is that of a water supply, without which plant life cannot exist, while animal life in turn depends for its existence upon vegetation. The only direction in which they can seek water is that of the polar regions, where it is alternately condensed into snow and released in the liquid form by the effect of the seasonal changes. It is, then, to the annual melting of the polar snow fields that the Martian engineers are supposed to have recourse in supplying their needs of the planet, and thus providing the means of prolonging their own existence. It is imagined that they have for this purpose constructed a stupendous system of irrigation extending over the temperate and equatorial regions of the planet. The canals represent the lines of irrigation, but the narrow streaks that we see are not the canals themselves, but the irrigated bands covered by them. Their dark hue, and their gradual appearance after the polar melting has begun, are due to the growth of vegetation stimulated by the water. The rounded areas are visible, where several canals meet and cross, are called by Mr. Lowell oases. These are supposed to be the principal centers of population and industry. It must be confessed that some of them, with their complicated systems of radiating lines, appear to answer very well to such a theory. No attempt to explain them by analogy with natural phenomena on the earth has proved successful. But a great difficulty yet remains: how to explain the seemingly miraculous powers of the supposed engineers. Here recourse is had once more to the relative smallness of the planet. We have remarked that the force of gravity on Mars is only 38% of that on the earth. A steam shovel driven by a certain horsepower would be nearly 3 times as effective there as here. A man of our stature on Mars would find his effective strength increased in the same proportion. But just because of the slight force of gravity there, a Martian might attain to the traditional stature of Goliath without finding his own weight an encumbrance to his activity, while at the same time his huge muscles would come into unimpeded play, enabling him single-handed to perform labors that would be impossible to a whole gang of terrestrial workmen. The effective powers of huge machines would be increased in the same way. And to all this must be added the fact that the mean density of the materials of which Mars is composed is much less than that of the constituents of the earth. Combining all these considerations, it becomes much less difficult to conceive that public works might successfully be undertaken on Mars, which would be hopelessly beyond the limits of human accomplishment. Certain other difficulties have also to be met, as, for instance, the relative coldness of the climate of Mars. As its distance gets considerably less than half as much light and heat as we receive. In addition to this, the rarity of its atmosphere would naturally be expected to decrease the effective temperature at the planet's surface, since an atmosphere acts somewhat like the glass cover of a hothouse in retaining the solar heat which has penetrated it. It has been calculated that, unless there are mitigating circumstances of which we know nothing, the average temperature at the surface of Mars must be far below the freezing point of water. To this it is replied that the possible mitigating circumstances spoken of evidently exist, in fact, because we can see that the water vapor condenses into snow around the poles in winter, but melts again when summer comes. The mitigating agent may be supposed to exist in the atmosphere, where the presence of certain gases would completely alter the temperature gradients. It might also be objected that it is inconceivable that the Martian engineers, however great may be their physical powers, and however gigantic the mechanical energies under their control, could force water in large quantities from the poles to the equator. This is an achievement that measures up to the cosmical standard. It is admitted by the champions of the theory that the difficulty is a formidable one, but they call attention to the singular fact that on Mars there can be found no chains of mountains, and it is even doubtful if ranges of hills exist there. The entire surface of the planet appears to be almost as smooth as a billiard ball, and even the broad regions which were once supposed to be seas apparently lie at practically the same level as the other parts, since the canals, in many cases, run uninterruptedly across them. Lowell's idea is that these somber areas may be expanses of vegetation covering the ground of a more or less marshy character, for while the largest of them appear to be permanent, there are some which vary coincidentally with the variations of the canals. As to the kind of machinery employed to force the water from the poles, it has been conjectured that it may have taken the form of a gigantic system of pumps and conduits. And since the Martians are assumed to be so far in advance of us in their mastery of scientific principles, the hypothesis will at least not be harmed by supposing that they have learned to harness forces of nature whose very existence in manageable form is yet unrecognized on the earth. If we wish to let the imagination loose, we may conjecture that they have conquered the secret of those intra-atomic forces, whose resistless energy is beginning to become evident to us, but the possibility of whose utilization remains a dream, the fulfillment of which nobody dares to predict. Such, in very brief form, is the celebrated theory of Mars as an inhabited world. It certainly captivates the imagination, and if we believe it to represent the facts, we cannot but watch with the deepest sympathy this gallant struggle of an intellectual race to preserve its planet from the effects of advancing age and death. We may, indeed, wonder whether our own humanity, confronted by such a calamity, could be counted on to meet the emergency with equal stoutness of heart and inexhaustibleness of resource. Up to the present time we certainly have shown no capacity to confront nature toe to toe, and to seize her by the shoulders, and to turn her round when she refuses to go our way. If we could get into wireless telephonic communication with the Martians, we might learn from their own lips the secret of their more than Roman recovery. Chapter 14.